Hi everyone, today we're going to be working on some applications of circular functions using your CAS. Now when it comes to circular functions, we tend to use them to model things that cycle or have a very periodic behaviour. So things like tides, sound waves, biorhythms, they use them for things like your electrocardiogram, so your heart monitors, just to cycle something that really does repeat itself after a time. In the case of circular functions, your independent variable, so your x, is usually a measurement like time. That's the most common one because you're cycling it over a period of time. And then your y can be anything like parts per million or height and that sort of thing. When you're working with circular functions in VCE methods, you want to make sure that you work in radians unless you're otherwise instructed, but most of the time your radians will work out quite nicely and you'll get your decimal answers from there. We still work with our two general equations, so our sine and our cos, with our mean and our amplitude and any dilations that might occur. We don't tend to use tan in applications. As you know, tan has that really funky shape, and there's not really any applications that are just undefined at a period of time. So they're not very commonly used in application questions. We're going to work through some, making sure that we highlight things like keywords and what the question's actually asking for. This first one here, there are parts of it that you can just answer by hand, okay? But if we had a look at this, we've got a type of bacteria and its concentration at a particular beach over a 12-hour period is modelled by this point here. Now we can still pull out some of the stuff that we like to look for when it comes to circular functions. So we can see here that our amplitude is 0.05. Our period is going to be 2 pi divided by pi over 12. So once we do that, 2 pi divided by pi over 12, you're going to end up with 24. So that means that this particular bacteria, it cycles these concentrations over a 24-hour period. And then we have our mean value still being 0.1. So our maximum and minimum levels we can find without using a calculator. For our maximum, we can just take that mean value and add on our amplitude. And in this case, we're going to get 0.15 parts per million. So don't forget to keep using the units that you're given. Same for the minimum. We can take our mean value and then take away that amplitude. And our minimum is going to be 0.05 parts per million. So it never actually gets to 0 bacteria on the beach, which does make sense because bacteria multiply and then they die off, and so on, so on. Now, if we want to find the level of bacteria at 3 p.m, you have two options for this. The first is that you can use your calculator or you can graph it. Now, the later question here asks us how long it's above a certain level. So you can just use your graph for both of these points here. Now, I would suggest don't use a graph pad. Actually open up a document. It's a lot easier to keep track of that way when you're in something like a test. But we're going to write our function in here. So we've got 0.05 times sine, and in our fraction, we're going to need pi times x. So remember, because x is the one that's defined in your calculator, you just replace any variables with x, and then plus 0.1. Now it's going to look like this to begin with, and that's just because our axes scales just aren't quite right. One of the easiest ways to fix this is to go Menu, Window Zoom, and then Zoom Fit. The other thing you can do is, because we are often working with quadrant 1 of the Cartesian plane when we're working with applications, if you go to that window zoom tile again and you click 6 for quadrant 1, it's just going to put you in the positives only. From there you can zoom wherever you like. I really like Zoom Fit, and then I like to zoom out a little bit just from there to see what's really going on. Okay, it just fits it nicely on your screen. I like to then just get rid of that label there because we don't really need it if you're not graphing multiple things and you can't tell which one's which. Okay, so in this case, I've just got my nice little sine graph here. Now, the first question is asking what the value is at 3 p.m. Remember that we're working with hours after 6 a.m. That's something really important to highlight there. and that 3 p.m. is actually the same as 15 o'clock. So we're looking at 9 hours after the fact, okay? So that means I want to find out what happens when my x is equal to 9. Now, you can, like I said, chuck that into the calculator and you would have had 9 pi over 12 in that sign bit. But I'm going to use the graph trace function. So you go menu 5, graph trace, and we're going to go over to 9, which is just there. Now, we want that correctly rounded to 3 decimal places. So all you've got to do is say that when t equals 9, p equals 0.135, all right? And then you would say your parts per million being your unit, all right? With graph trace, you might find that yours isn't going up by 0.5 nicely like mine was. In that case, if you go to graph trace and you go trace step, if it's not doing what you want it to do, you can tell it what you want that step to be, mine being 0.5 that I like to work with. Other times you might want to use a graph step of 1 or even 0.1, depending on what it is you're working with. Now, the next thing we want to know is how long we're above 0.125 parts per million. Okay, and there is a really easy way to do this. If you double click your screen, you can add another graph. And what this is saying is that P is equal to 0.125. In this case, P is our Y, so I'm going to just chuck a line in at 0.125. Then it's a matter of finding your points of intersection here, okay? So I'd like to write this out as kind of like interval 1, interval 2, and then if we need to do any conversions for minutes and that sort of thing, we can do that later on. Now, to find those points of intersection, you're going to go menu and then 6 for analyze, and then 4 for intersection. It is going to feel a bit repetitive at the time because you're just finding every point of intersection that you can here to then work between there. Now, because we're looking at how long, we're going to be working with our x coordinates in this case, not with our y coordinates, because our y coordinate here is that 0.125. Okay, so here's all my coordinates. My first interval is from 2 to 8, and then my second interval is from 26 to 34. So they're both 8 hours. So the level is above 0.125 for 16 hours because we've got that interval there. Now, in this case, because we're actually only looking at the first 12 hours, we actually have to discount that second 8 hours that I found there because our graph should have ended after 12, so after x equals 12. All right, obviously with 26 and 34 being greater than 12, it is just that first interval, so the level is above that 0.125 for 8 hours. So don't slip up like I just did where I forgot about the domain that we were given, okay? But that's how you tackle that sort of question. We're going to tackle another question which has a bit of a trickier interval to work with, and we're just going to give it a go anyway, okay? So our next example here, we're looking at the height of tides. Tides tend to work in a cycle, especially with the moon and that cycle, and so they're a nice one to graph and analyse, okay? Now, in this case, they're wanting your graph just between 0 and 24, and we can get our CAS to do that, right? So I'm going to type in my 4 times sine, get that fraction going. Don't forget with pi, you can just write pi, and I'll do pi times x over 6, and then we've got no vertical translation there. So our mean value is going to be at 0, and now our graph doesn't fit too nicely. So I'm going to do my window zoom and fit to get it to sit nicely. Now, because you have that domain that you've been given, we can put the same domain in our calculator. If you click Control and then Enter, you're going to get this straight line here. If you do that straight line, that's like a given that, and that's how you can specify your domain. Then I'm going to say I'm going between 0, and that's going to be less than or equal to x, which is less than or equal to 24. And that's going to, as you can see, completely shorten my graph there. Then just to zoom it in nicer, I'm going to try to do quadrant 1. And that just zooms in nicely on that and get rid of that label because we don't need that. All right, but here's our graph. I might actually make that back to a fit so that I have the whole graph there in front of us from 0 to 24. Now, when you do draw a graph, we would like to at least have one minimum point and one maximum point as well as any intercepts. Sorry, that should be a T. But yeah, as well as any intercepts that you might have as well. When you're sketching a graph and you haven't been given an axis, your scale doesn't matter too much as long as it looks relatively, pardon me, that looks horrendous, but as long as it looks relatively even, you are fine. And that still looks bad, but you get the gist there, okay? This part here is at 24, and so that's 24, 0, and this is 0, 0, which does check out for a sine graph. Now, if we want to find any intercepts, if you graph trace, it is going to automatically stop here. See how we've stopped at your x-intercept? So this intercept here is 12, 0. And if we were to click to the left here, our intercept here, once again, 6, 0. So graph trace will automatically stop at your intercepts. The other thing that graph trace will automatically stop at, is at your minimum and maximum. So if I do graph trace, it will automatically stop there and say minimum. So we have a 9, negative 4. And then if I just want to pick up one of my maximums, I'm just going to click that on over and it's going to stop at the maximum as well. Okay, so at a minimum, give us your x-intercept, your y-intercept, and one minimum, one maximum. Now, it's asking what the height of the high tide was. That's still just your amplitude plus your mean value. So in this case, it's going to be 4 meters above that mean sea level. Okay, now we don't know what the mean sea level is. We just know that we can't have a tide that's technically zero, like below 0 meters on the ground. So you have to remember that this axis here is your mean sea level. So your y-axis is your mean sea level. Okay. Now it's asking you when high tide was. We're going to be looking for those 2 maximum points, and it's the number of hours after midnight. That's something key to take from your question there. So we know one of our points was at 15, and we can just do our graph trace all the way back up to our other maximum to get our 3. So high tide in this case was 3 hours after midnight, which is 3 a.m., and 15 hours after midnight, which was 3 p.m. Now, if we want the height of the tide at 8 a.m., remembering we're working that number of hours after midnight, I'm just going to go through until I find x equals 5. And now remember, in this case, we can't have a height of negative 3. The way that you would write this out is 3.464 meters below sea level, mean sea level. Okay, so we can't be negative. You do have to remember you're working below the mean sea level, not the ground level. Okay. Now this last question here is that one that I was telling you that was a bit tricky. Your boat can only cross the harbour when the tide is at least 1 metre above sea level. So when we put this into our calculator, we're going to make our f of x equal to 1 to get that straight line across. So I'm going to double click here and click 1. And I've got my straight line here. So now I need to figure out those 2 intervals that I can see that are those safe intervals for a boat to cross. So I'm going to have to figure out interval 1 and interval 2. And because we're working with our x values, I'm going to look for those points of intersection and those x coordinates at that point. So I'm going to analyse and find that point of intersection. So we can see one of them is 0.4825, 837, which is a bit gross to work with, right? But that's interval 1, and we can get rid of that intersection there. The second point of that interval, if I intersect here, was 5.51 7416. Okay, so to get how many hours that is, we're going to have to subtract. Once again, I've told you earlier that intersection points are just repetitive. What you'll realize as well is that usually one interval is going to be equal to the other interval. Now, I've written that down wrong, so bear with me there, but 12.48258. And then I just need that last interval as well. So I'm going to analyze intersection, and that's at 17.51742. 17.51742. And it'll be 16 because it matches up with that one. Now that we've got these gross intervals, we need to actually figure out what their times are. Working with decimals is quite gross, but we're just going to have to do it. So you're going to open up your calculator, and we're going to find the difference for each interval. Use as many decimal points as decimal places, as you can, until you get to your final answer. So 5837. So our first interval. So interval 1 is 5.03483 hours. Okay, remembering that we're working in hours. Interval 2, we can see, would be the same thing because we've just added 12 to both. So same. So to get our total, it's going to be that interval times 2. So I want my answer multiplied by 2. Is 10.0697 hours. And then we have to turn that decimal place there, into minutes, right? Because we're not going to give an answer as 10.0697 hours. We're going to give it in terms of minutes. So I'm going to take this bit here because that's still in hours, and I'm going to times by 60 to get my minutes. Oops, sorry, did not take enough there, but 0.0697 times 60 is 4 minutes. So 10 hours and 4 minutes is how long he had to cross. I've just realised that was not the question that we were meant to be answering. So I've just answered a different question entirely, but it's all good practice in the end. Our first interval, we're actually going to change that into a time. So we can see here that interval 1, we can cross from 12 something a.m. through to 5 something a.m. And then interval 2 is going to be the same minutes, but the hours are different. We're going to cross through at 12 something p.m. through to 5 something p.m. And now we just need to figure out those somethings. So to do that, I'm going to write out the decimal places and then times that by 60, because currently those minutes, that decimal place is in hours. So that becomes 28, which is 29. So from 12:29 a.m., which means we'd have 12:29 p.m., through to, and if I type this in, 0.517416, if I times that by 60, I get 31. So that'd be 5:31 a.m. and 5:31 p.m. So this here, if I had read the question properly, you would see is the actual answer to the question because it asks when the boat could cross. Okay, so you get those ugly decimals and you do just have to turn them into minutes because we want the times there. Okay, hopefully that wasn't too confusing, but feel free to give those worded questions a go on your CAS.